And then what I would also like to do is, I will take you through the work I have been carrying out since 1978 in the coastal zone of Kerala until 1992 or 1993, with funding was sponsored by Ministry of Environment and the Government of Kerala and so on and so forth. In addition to that, what I would also want to throw light upon is the need for a revised scheme of mapping of the coastal zone of Kerala. In other words, Dr. Sabu made a mention of 237 villages, etc., etc. But what is not immediately available is number of people, citizens, who are directly exposed to, who are directly facing every morning the shoreline, which is very close to their own homes. So these are the things I would want to address here. Now, this slide is actually a very important slide in the sense this was published in, way back in 1972. This picture is actually portion of a picture which is actually a creation of Mary Tharp and Bruce Heason of Columbia University, New York. This creation was funded by the National Geographic Society, and this is actually a 3D relief map of the Earth, not only the terrestrial Earth, also includes the seafloor of the Earth. So look at this. Please go to focus your attention on the west coast of India and compare to the east coast. West coast is nearly as wide as east coast, except that in the region of Gujarat and of Maharashtra, it is very wide. You may make note of the fact that the widest portion, no, south of the Gujarat, the thumb-like projection of Gujarat, the peninsula, that is where we have the Bombay high oil field, which has been a very important life-saving source of oil for the entire Indian country. In 1974 or so, the oil was a wild discovery. It is actually a wild cat discovery, as the industry calls it. In other words, you were not prepared to receive any oil, collect any oil. Only thing is, it was people were trying to. Technology was being used to drill and figure out whether or not there is oil, but there was oil. So as you come down toward Kerala, for example, or up to Kanyakumari, the shoreline is getting, no, the continental shelf is getting narrower. What is the continental shelf? Because continental shelf is a very important physiographic division of underwater that is going to decide which way our waves during the monsoon are going to be approaching the shore and how effectively they will approach the shore. So that is the reason of keeping this map here. When you go to the east coast of India or the Bay of Bengal side, you can see the Bengal fan right there. And also, what is important about the Bay of Bengal? Bay of Bengal has been one of the top 10 bays in the world, and where very severe cyclones are experienced annually. And our monsoon also on the west coast is associated uh, with the annual feature, which is called a summer monsoon, because as soon as the summer is over, we have the coastal erosion or monsoon setting in by the 1st of June every year. And in fact, you know, maybe 50 years ago or 30 to 50 years ago, the onset of monsoon in the Kerala coast, especially in the region north of Tottapalli, was earnestly looked forward to by the people who are the fishers there, because that is called the Chagara season. Chagara is also in English, it is called mud banks. The founder of Cochin Port, Mr. Bristow, the designer of the Cochin Port, Mr. Bristow, was the first person to go on record about the scientific basis of the Chagara or mud bank. What is the advantage of the mud bank? As soon as the mud banks appear offshore of the segment between Tirkunapura and Alapura, let us say, what will happen is the sea will become immediately calm. So that will allow the fishers to venture into the ocean, coastal ocean and go for a big bonanza of fish catch. It not only attracts local fishers, but it is attracting fish workers and business people from Malabar region and Karnataka, as well as from Tamil Nadu, parts of Tamil Nadu. But these days, for example, this year, during July, there was not even a single word printed about chakara in this area. Well, when you look into the literature, you will see that chakara is a phenomenon, or the mud bank is a phenomenon that can appear anywhere between Trikunapura in the south and the north pier of in Calicut Beach. So, in other words, chagara or mud bank is not a thing which will appear only in one place. It is migratory in nature. What is chagara? It is actually, the monsoon waves. Well, they are very special. They have very long periods, like 10 to 13 centimeters, 13 seconds, and always, the what is called a significant wave height then will be like more than 1 meter. When you say you have a 250 to 300 meter long wavelength, it means that almost as soon as these waves reach a depth which is half of the wavelength, the bottom sediment will feel the presence of waves riding over the water. So then the sediment in the bottom will be stirred up, finer sediment first, and later on the coarser sediment will not come up, but it will move down, move up or down, whatever. So that suspension of finer particles will bring over huge volume of nutrients, which will attract what is called the schools of fish of different varieties. And that is what this chakra is. There is a helpful role played by chakra, because during the chakra season, during the mud banks, it is actually like a submerged breakwater, offshore breakwater. It will protect further erosion of the beaches. So that much for mud banks. Without a mention of mud banks and its protective role to the beaches, any kind of examination of the coastal erosion will be inappropriate. So now, next slide, please. Sabu, next slide. Well, you have to look at the classification of coasts. This is based on the morphology. Coast, okay, coast is the importance of the shoreline. Shoreline is the intersection of the three spheres, all the three spheres of the earth. That is where the lithosphere, that is where what is called the hydrosphere, and that is where what is called the atmosphere are cut across. That is the importance of the shoreline. And the shoreline, therefore, on the land on the land side of the shoreline, which is of interest to us, that is actually had attracted attention of geomorphologists or geologists, right from Johnson, from Columbia University, Carton, and then Francis P. Shepard, a famous marine geologist, another the younger generation man by the name Valentine. And what they all took into account the recent sea level changes and the tectonics and how tectonics affects the morphology of the coastal area was addressed by Inman and Nordstrom. And the next one, please. Next slide. Well, what is the coastal zone? Well, coastal zone is actually divided into three. Coastal land zone, that is then shore zone, and then shelf zone. Shore zone is the narrowest of all. In other words, it is between the region defined by the backwash and swash limits. Backwash and swash. What is the coastal land zone? By definition, it is the area on the land side of the shore zone, but where the activities, processes, and problems of the shore zone will be felt by the population. And what is the shelf zone then? Shelf zone is beyond what is called the shore zone. Shelf zone actually up to continental shelf. Well, there is a, how do you put the limit to the continental shelf? Because there will be a break between the shelf zone and the beyond a certain point, break in the slope, a higher slope, which is called the continental slope. So For example, go back to the first slide, in your memory, in the first, no, don't go. Okay. Yeah. What has happened there is in the off Bombay, off Gujarat, what is called a shelf is so wide. Whereas when you come down toward the south, toward Kanyakumari, and if you reach Kanyakumari, the shelf is wider. But with north of Kanyakumari and up to Kochi or Mangalore, the shelf is relatively compared to what we have up in the Maharashtra region or Gujarat region, it is narrower. Next one. Next, please. Well, there is a manual, as it is called, shore protection manual. See, this is actually by the U.S. Army Corps of Engineers. This book, it was published way back in early 1950s. They keep on revising it, and they have some. Why would Americans would be interested? The technical and scientific people interested in their coastal process, their coastal zone, their shore zone, etc. The reason is very simple. For India, we have 5,700 kilometers of mainland shoreline, and roughly 3 times more is the extent of the shoreline for United States. They have the Atlantic coast, they have the Gulf coast, they have the Pacific coast. So all these put together, don't think that those shorelines are very safe and that the coastal line is also very safe. It is one of those regions in our mother earth where all the problems that we face in Kerala probably are faced much more severely by those people or the communities that are settled along the Gulf coast or the Pacific coast or the coast of the what is called the Atlantic coast. Well, for example, there is a classic example of what is called a Long Island. The Long Island has also what is called a shoreline on the north of it, to the west of it, east of it, and to the south of it. And this shoreline is under continuous erosion. But of course, they are avoiding actually, investment in the coastal land, especially the backshore of the area, cannot be encouraged. And even if possible, it should be prevented by regulation and law. Was actually the invention of the U.S. Army Corps of Engineers' mind. So, unfortunately, we have no such mindset with us. Okay, look at the causes of erosion. Sea level rise. Sea level rise, for example, in 1952 was not a problem. Those days it was called, in other words, engineers and coastal geologists only address what is called the eustatic sea level rise. Eustatic sea level rise is something that we cannot do. In other words, the terrain, the land area will gently go up. Not one certain region, but the whole plate will go up in its elevation. So that was the eustatic. And then let us go to the next one, variability of sediment supply. The California coast was undergoing severe erosion, and in those days, in the 60s and early 50s, what was the the concept was, philosophy was, there were so many dams built to prevent in other words, reduce the supply of sediment and water to the ocean. Because of the lack of supply of sediment to the ocean, the beaches were facing loss of sand, or beaches were rather eroding. Well, of course, we had also in Kerala toyed with the idea that because, we have built several major hydroelectric dams for storing water for power production. What has happened those days was our thought to us, because, we think always with the rest of the world, but only a second to the rest. And well, that, because these dams are going to what you call store the water along with sediment. But those days I had a strange, different feeling. The dams do not block the flow of the entire water in the basin. One. Number two, therefore, the sediment that is supposedly going down through the river channels are not entirely cut off. And so, therefore, in other words, if The entire sediment were to be cut off, our dams will get silted up, and it will be only a marsh. So that always, of course, such a points of view does not get most of the time currency. Then it storm waves, yes. No, unfortunately, these days we have more storms. For example, in 1977, when I went to the India Meteorological Department, see Mr. Joseph, then presiding officer in that branch of the IMD in Trivandrum. I was talking to this gentleman about the role of what is called the storms in causing coastal erosion. So I am a geologist, but that man is a very seasoned meteorologist. And we were very good friends, later on. But he said, what do you mean by storm? We don't have any storms here. That is the exact answer he gave. Then, of course, I was just snubbed rather. And okay, then, what is the reality now? We have depressions. We have what is called a Pati Volata depression, IMD in the Lakshadweep Sea. In addition to our storminess, which is coming by October, there will be several storms in the what is called Bay of Bengal. Wave and surge overwash. When you have a stormy nature, in other words, for example, during the normal days of outside of the monsoon, occasionally we get a news in the paper printed like this. Punnapura Kadapurtha, there was overnight there was a storm, and it flooded all the homes, etc., etc. Or else it will be like, for example, in Pundra. So this is actually something which is not affecting the entire coast, which is not a disturbance which affects most of the atmosphere along the coast of Kerala, instead local features. But I have a slide relating to, I think, a 1981 7th Onam storm in the Arapad area. Then deflation. Well, of course, dunes are in other words, our winds are not very active in removing the sand landward. The reason is very simple compared to, unlike what happens in the east coast of India. In the west coast, what happens is we have a huge tree line. You know what the tree line is, and you know what the tree is. It is only coconuts. So, this is a big barrier. In other words, instead of planting, like our under social forestry, casuarina to prevent or stabilize the shoreline, they should actually what our forest department, social forestry wing should do is planting coconut trees, which is actually useful because coconut trees they yield something which is useful. That is the advantage. So, I have a call. That's all. Okay. Let the man call and then cut the call. Okay. Now, long-shore sediment transport. This is a very important aspect. In other words, most of us, unless you go to the beach, unless you have an introduction about what is the littoral zone, etc., you will not realize what is the long-shore sediment transport. For example, many have suggested that many previous workers in Shangumugam beach in Kerala, Trivandrum, the beach is disappearing, beach is built back. So immediately, this is what influences the mind of our local MPs or MLAs or even the ministers in order to rebuild the beach and the beach road. It is as bad as the erosion of the coast. Whatever you invest, whatever you build there will actually be useful only for 6 months, because the next monsoon it is all eroded off. I suspect that is sooner than later arrive in Trivandrum when the indoor court itself will be in danger or endangered. Okay. Now, anthropogenic or man-made, these are the things, reduction in sediment supply. I had off and down, digressed into this also. Increased water, okay. Sea level rise is a phenomenon we have to address. Sea level rise is taking place at the rate of at least 1 millimeter per year. And all the coastal states, including islands, they are going to suffer the consequence of sea level rise. And this is something we cannot stop. This is the whole point. We have to learn to how to not affected by the sea level rise consequences. There is a great scientist by the name Per Brun. He had suggested a concept. For every unit of rise in sea level, there will be 100 units landward. That there will be a disaster. You may think that there is a 1 millimeter, only 1 meter is affected. Well, think about it. For instead of 1 year, take a decade, take a 50 years. What will happen? We can perceive, average humans can perceive what we see only through the eyes. Mind won't work. In fact, what will happen is, think about the aquifer and what is the future of the aquifer. Think about what is called whatever we are buried by way of something made of iron as part of concrete or a pipeline or what have you. What will happen to it? With the influx of seawater, these are going to be ruined and at a very huge cost. Next slide. Next slide, please. Sabu, can you hear? Next slide. Can I have the next slide, please? Thank you. Well, this is a tectonic classification of our coasts, in global classification. In this, I invite your attention to narrow shelf hilly coast and a narrow shelf plain coast. And what I have given here, these two are what applies to Kerala. Narrow shelf plain is our shelf area of Kollam to, let us say, Thrissur or Kochi, Padanapalli. And narrow shelf hilly coast is, example is Trivandrum district or Varkala or up in what is called Kannur, where we have coastal cliffs. Okay, the next slide. Next, please. Well, this is actually very apt slide because the sea level stood once upon a time very low, no doubt about it. Thousands of years before present, that is what it says, DEPT. Zero is now, okay? Zero is now, and zero is the zero now, it is today, and zero is the present day mean sea level. But look at 15,000 years from now back, 15,000 years backward, then sea level stood so low. The reason was we had what is called the glaciation affecting the continents and the countries in the northern latitudes. That was the reason that we had at a low sea level. Now we have some ice left. We have continental ice sheets. We have the Arctic ice sheet. We also have the Antarctic ice sheet. Unfortunately for all of us, globally, all these are wasted. And our sea level, for example, if all the ice in the Antarctic and in the Arctic, not even that, if the Greenland ice sheet disappeared, 61 feet of water will rise, sea level will go up by 60 or 61 feet globally. If the Hindu Kush mountains in India, in Asia, the ice sheet there melts, Afghanistan, Pakistan, India, Burma, Bangladesh, and even China will, including Tibet, will suffer water scarcity. And why would it disappear? Because of the global warming. This is going to be a great threat for, I don't know, underline and say that global warming is a great threat. It is a great threat. It is accepted as a threat, but what we do, we are doing nothing about it. Okay, the next slide. Well, this is what is the driving force? Well, this curve is not the most modern one. It is up to only 1998. This is called Mauna Loa curve. The interesting thing is the scripts in oceanography has established a carbon measuring laboratory in one of the islands in the Hawaiian chain. That island is called, the volcanic island is called Mauna Loa. And it is called Mauna Loa curve. And it was established by atmospheric scientists used to work for the Scritch oceanography. And they have been measuring the carbon dioxide right from 1952 on. Currently, the funding for the maintenance of operations is from the Melinda and Bill Gates Foundation. This, this curve is very significant, very important. Look at the type of part per million, the carbon dioxide content. You know, we had started with something like 310 or plus carbon dioxide, and now it is gone up to 370. Currently, today or last week, it was 413 parts per million. That is the carbon dioxide content. And Arrhenius, a German chemist, European chemist, let us say, he had one, you know, not now, not in this century, or in the 90s, early 90s, that our exploitation of what is called fossil fuels is going to release a lot of carbon dioxide primarily. And the accumulation of the carbon dioxide in the atmosphere, because no other place it can go to, it will create some kind of a hothouse effect. That are what is called the global warming, as we call it now. So this is something something people dreamt about last year or last decade. It is as old as Mr. Arrhenius is. Okay, the next slide. Next slide. Okay. Now this is the very interesting curve. This is also showing the sea levels in different locations, different observation points in across the world, and you know, it is measured and printed here in meters on the right hand side. This is what happened in the Holocene, that is from 8,000 years before to present day. You may wonder how you go and measure the sea level rise in 8,000 years ago. How do you measure it? Well, of course, you know, scientists are very smart. They are always thinking about, you know, this is the advantage of a scientist. If you have a problem, like for example, we say, they will be thinking about the solution. So that is how it has been possible to predict what happened, what was the sea level then those days. You know the ecology of the oceanic coastal waters, and of course there are several isotope methods of dating, or even determination of the composition, and you know, you can always interpret. You can always come up with a measure of position of sea level. Okay, the next slide. Thank you. Well, I think I made a mention about the narrow shelf plain coast as well as wide shelf plain coast. The narrow shelf example is our, you know, Varkara, Thiruvananthapuram, Kovalam, or Karichal, or what is called Animanathura and so on. And our wide shelf is actually where off the Vembanad Lake, Vembanad Kayal, or the what I call the strand plain of Kerala. Okay, next one, next. Well, I think you can, these numbers we can keep in mind. You know, I say in the first sentence, land inundation, 5763 kilometers square or 41%. Population affected, 7.1%, 1 million or 4.6% of the coastal area. This is actually a report by theory. You know, you can see which are the coastal areas coming under this kind of situation. Kutch, Mumbai, South Kerala. Yes, Kerala is included there. The study was in 1996. That is quarter of a century ago. That is what you should say. You should understand. This 2020, it was published in 1996 by TERI, New Delhi. So we are not very safe in Kerala, especially, you know, all those people who live in the coastal districts. That is actually Alappuzha and then Ernakulam and Thrissur. They are going to be affected terribly. And the only solution is not rebuilding what we lost, but going away. That is the safest. We cannot fight a natural force. We have to escape from it if we are smart enough. Okay, the next slide. Well, this is actually a 1972 satellite image. Landsat image actually. Landsat 1 image actually. It is still there in the Karyavartan Geology Department. And you can see what I mean. The black, this is actually, I think, a band 4 or band 7, because that is what gives you the greatest contrast between water and land. See this, you can see the Vembanad Kayal, and also what is called the wetlands or whatever of Thrissur, and the sea is. I have one suggestion: please don't call or use anymore the words Arabian Sea. The Survey of India has long ago suggested the name the Lakshadweep Sea for our sea. So what are the things that are marked? I marked Kayankulam and I have marked Alappuzha. You can see Thottapalli if you like, and you can. I have marked something like Cherthala glass sands. And this Cherthala glass sand is a very interesting deposit. Very interesting in the sense, this is the best example of what is called a littoral drift. This is the best example of what is called a longshore drift. This is also the best example of Kerala's, a signature of Kerala's dominant drift direction. What do I say? From Chavara to Kayankulam, we have the world-renowned black sand deposits. Keep that in mind. From Kayankulam, Chavara to Kayankulam, we have the world-renowned black sand deposits. Beyond that, we have what is called the glass sand deposit. What is the average specific gravity of the black sand is 4.0, whereas average specific gravity of glass is that of quartz, 2.65. So unless we have a drift, we have a littoral current dominantly heading toward north or northerly, you will not get this kind of separation. Right from 77, I have been shouting the slogan, but nobody believes, nobody, well, of course, nobody, I shouldn't say cares to, nobody appreciates it, because there are hundreds of other things we can appreciate. Another interesting thing you have to keep in mind is, another example is the Kovalam area has, Kovalam, the north side of the Kovalam headland, has a black sand accumulation concentration. When you go to so-called, very famous Sangumam beach, those sands are glass sand, glass quality sands. Not only that, they are called the singing sands of Kerala, Travancore. Singing sands of Travancore, because first of all, it is glass quality, and I will come to that anyway. There is a cyclic process of erosion deposition taking place in Sangumugam. One of the consequences of the cyclic process is, in other words, the presence of glass sand on the singing sand in the land area, including the airport, current airport, etc. The substrate material is a sand. One, it is of glass quality, that means very low level of what is called the other minerals, under 1%, that is one. Number two, if you kick the sand, you will hear a swish sound. There are very few locations all over the world, very handful only, where the sands have this behavior. And this has been attributed to high roundness of the sand. I am saying that this high roundness is the result of cyclic erosion and again reappearance of the beaches, cyclic deposition. A cycle of erosion followed by deposition, and a monsoon to monsoon basis. So during the retransport toward the land, the sand particles are actually extremely well upgraded, and naturally what you get is a higher roundness. That is the reason for the so-called singing sand. Now, if you went to north further, what you will find is you will have again a pair of glass sand and black sand. Well, this picture I have put here, this is something like 1981, 7th Onam Swarm and the consequences of. It is some place between Alappuzha and Kayangulam. And Dr. Anil then was the person who accompanied me. And it is a storm that swept over the area overnight. You know, if you went there, you will not see the type of people there who used to live there were extremely, what shall I say, below poverty line people. They depend for entire needs only on the resources of the sea. And yes, what had happened? You know, it is not only overtopped. Look at the first figure. The figure is looking to the south. Look at the second figure. I'm looking through the newly deposited layer of sand in between the coconut trees. This is due to a storm overwash. And the figure left to bottom is again another view of the first picture. And then on the right bottom is the picture, a close-up view of what had happened to a storm that acted for 1 hour on the 7th Onam night. Okay, this is an example of a hilly coastline. This is the Varkala area. This is again a Varkala area. This is our Varkala, you know, Pavanasam beach. But you know, this my class was there. These guys are almost retiring and retired now. And then what you find at the bottom layer is actually the Adimanathura region. If you went there now, you will not see the different sediment layers there because our forestry people have just planted with the casuarina all the slopes. You know, in other words, you know, everybody, when you are in the charge of a department, an organization, they do not consult other people who are also well versed with the processes, well versed with the morphology. They said, we are going to plant. We want to save all the cliff. You know, whether you plant it or not, you cannot save a cliff. But there is another picture, you know, this picture is actually the road, link road from Gadava to Kollam. And you can see the ocean on the left side, and also on the right side, what you see is the Karanam, the Gadava Kayal. And these stones here are actually for use to protect, kind of riprap it is called. Then of course, you know, you see this little slate when somebody holding that slate. Well, that is our study during 1979. We made a study from Kanyakumari up to Kasaragod along the beach. And the picture at the bottom left and picture on the bottom right also is the pictures taken at different places during that study. And that was a very interesting study because we had a good deal of first-hand view of what happens in the Kerala coast. In other words, it is impossible. Now, it is the 2004 tsunami, December 26th. What had happened? You know, now there is a huge hue and cry about the mining sea sand. Look at the resource. They're all black sand. You know, it's very expensive sand in the international market. Here is also, you can see, of course, the left side is what the harm that tsunami did. The right side, the top is the sediment that is brought in. The left side, the bottom is also what is the black sand that is brought in. And on the right side also, what you find is, you know, the position on the backshore area during the tsunami. Next one. Well, of course, you know, this is something about the currently practiced protection, shore protection. You know, most of the people in the audience would not know why these sea walls were constructed. There's a story about it. The sea walls were constructed way back right from 1950s. You know, I made a mention of the Shore Protection Manual and the US Army Corps of Engineers. You know, Americans are there. They're always, you know, pretend are real good Samaritans. So when they understood, when Indian government contacted the Americans for help to do something about the coastal erosion, especially in Kerala, they had deputed 2 engineers and they came down to Kerala and to what is called, one second. Sorry, one second. What? No, I am sorry, I had an unexpected visitor ringing the doorbell. But anyway, so I think Mr. Watts was one of the engineers, one of the two American engineers who came and supervised the building of a seawall. That is number one. Number two, they also tried what is called a beach nourishment. In other words, when you lose sand from the beaches, what you do? Either nature itself brings back the sand, or you provide an artificial beach nourishment. In the American situation or European situation, what is done is sand or sediment from the offshore is pumped as a slurry over to the eroding beach. In Kerala, that is not possible. Say, it is 1952, early 50s, there was not even Kerala. So what was done was, we had an army of people, men and women combined. The women are working like a conveyor belt, and the men, two teams, one along the shore face where the American engineers told put the sand here, etc., and another team working on the backshore, deep backshore, collecting the sand in a basket full of sand and loading it on the head of the women. Women, quote unquote, conveyor belt. So that was also tried. Well, what had happened those days, since then, government of India had set apart a huge sum of money, few hundred crores annually for building seawalls in Kerala. With that money, of course, money is so sweet, and the building of seawall is also a sweet part. What we have done is we created the Kerala Engineering Research Institute after Kerala came. And then there is a research, Mr. Mani is a great research engineer, who used to serve in the early days of Kerala Engineering Research Institute in teaching. Well, then what? Seawalls were built. And of course, when, the people unfortunately had a wrong idea about the seawall. The coastal people, including our local politicians, what they thought was the seawall is the final answer. Because of course, you have to get a rock, you have to place them on the seawall. So there is a great coastal protection, coastal geomorphologist, Stephen Letterman. And he used to be working for what is called the University of Maryland, University Park, Maryland. And this man has made a very famous saying, seawalls are good as long as they don't founder. In other words, what happens is, the problem with seawall is, if in a different wave climate, on a certain years, during the monsoon season, if this the toe of the seawall is eroded, the stones will sink. Once the bottommost foundation stone sinks, what happens? Then the top will sink, and finally, after 5 or 6 monsoon, the seawall will be all buried under what is called a sand. So, and another interesting thing, we have built something like 292 kilometers of seawall to protect the Kerala coast. It is a living example. And we now hear about Chellanam and the severe erosion faced in Chellanam. But unfortunately, in Chellanam, there is one certain segment of seawall which is intact even now. So all those people who live there, they want a new seawall to be built. Now, the seawall is a huge investment. In the early, let us say late 1970s, 1 kilometer of seawall used to be 7 to 8 lakhs. Now it will be well over 1 crore. And where do you find the stone? Or is the seawall the final answer? Absolutely no. Well, of course, you see this beautiful beach, Pocket Beach. This is called a pocket beach because, these two headlands are there on the far end of the picture as well as the near end of the picture in the front. So during monsoon, you won't find this wide beach. This is summertime, so many people are there. This is the typical Pavanasam beach. The next slide. Next slide, please. Well, of course, some definition. Well, you will have these slides in the YouTube, and you can read up about all these things. What is coastal zone? What so on and so forth. But one of the things you have to keep in mind is the terminology. Our only in the cliff shoreline, that is 92 kilometers. I have made a measurement, estimate of the length of the so-called cliff shoreline in Kerala using the 1972 Landsat imageries, and it all added up to 92 kilometers. The rest of it is not what is called a cliff shoreline. And wherever you have a cliff shoreline, except for the instance of Varkala in the south, there is, for example, there I had to talk about one or 2 points about the importance of Varkala. See, at the southern end of Varkala, there is a cliff, Pavanasam cliff. There is a village called Chilakku. And then you have a flat area, I call it a graben. And when you walk further down toward south, all of a sudden there is the whole cliff section again. Through that cliff, there is a tunnel that is connected to the viaduct of the what is called our Parvati Puttanar that goes through the Varkala tunnel, etc., etc. And here there is what is called the Chilakkur landing. Chilakkur landing is like, for example, that is like a bus stop as far as the like thing where there will be a shelter, there will be people, and you can buy ticket and then board a boat or a vallam, whatever. So in the Chilakkur landing, it so happened that our intra-coastal waterway is very close to the beach. Now, very close in the sense, hardly 100 meters away from the beach. And therefore, way back in 1890s or 1880s, Sirti Madhava Rao's days as the Diwan, there was a battery of groins that was built here to protect the TS canal. So, go to the next one. Yeah, this is a definition diagram. Here, what you have is a wave, sinusoidal wave. You can figure out what is the wave height, what is the wavelength, and what is the amplitude, so on and so forth. Okay, the next one. Next one. But take a very good look of this diagram. This is from, I think, a shore protection manual. Be carefully looking at the topmost figure and compare it with the bottommost one. What had happened is the dune. Dunes are rare in Kerala, except unless you went to Bekal area. Of course, those dunes we had south of Bekal are now flattened and to enable cultivation of tobacco anyway. But you have still some remnants of dunes there. So you have which is actually a natural protection from storm surges and the coastal erosion and destruction of and loss of property. So what happens? When you have a rough season or monsoon season, for us example, the second figure will be more pertinent. Figure drop from 2. That is, there will be erosion. The berm will disappear. And then, in respect of a severe erosion, what happens is the dune is removed and, water will cross over, surging waters will cross over what is called the backshore area. Next one. Next one, please. Next slide, please. If you can hear me. Yeah. Well, look at this. This is actually something that I borrowed from where else? Wikimedia. And go to the previous one, please. Go back to the previous slide. If you can, you go back. Okay. Look at this. No, I intentionally I had put this. Go back to the. Can you do it? Well, it is about a longshore current. Okay. This is what you have to take into account or keep in mind, how the longshore current works and what is the littoral current. Littoral current is the current that is heading toward a certain direction between the shoreline and the breaker points, plunge point as it is called, plunge points. Well, of course, there are different types of breakers. You have plunging breakers, you have surging breakers, and you will have one more type. Okay, it will come. Next one. Go to the next, please. Yeah, this is a very interesting picture. You have to keep in mind. Look at the red colored, red hued parts in the Indian map. And there, of course, the red color indicates the most severely affected areas in our country, which will be affected by the sea level rise. Kerala is not excluded. The next one. Well, this is a picture of Kerala. What it shows is the physiographic division of Kerala as well as the districts of Kerala. You have the coastal land area, you have the midland area, and you have the highland area. I have given the elevations compartments also. Go to the next. Next one, please. Yeah. Well, this is something I should say I created. For example, all the plus signs indicate the basement rock, and the hump toward the right, where marked east, it is the Western Ghats. And then, you come down, you have a layer of sedimentary rocks, or then you have a lagoon. And I call the area between the, you can call it, you don't have to call it the foothills of Western Ghats. That is the better way. You have the strand plain. In other words, the sediment, which is on the left side of the picture, on the lagoon, topmost layer, these are the dune ridges. This is actually, for example, keep in mind one thing, our great Vembanadu Kayal and the Sherthala Alapura area is a donation once upon a geological time by our own sea, which is now threatening the lives and the livelihood of coastal people. This is a classification of the Kerala coast. You have several different types of shoreline. For example, picture A will be like representing an area like Kovalam. Picture 2 or B will be something like Kannur. And picture C will be something like what you have from Changanasheri to Alapura. And then picture, what is pictured at these, I interpret that there is a fault actually. There is a boundary fault that, thinking about a fault in Kerala is something unusual because the entire landscape, the morphology of the landscape, the orientation of the river channels are all related to some kind of a fault, which is dead now or dormant now, or some kind of a lineament, which is crisscrossing, not crisscrossing in the sense, which are regularly crossing the landscape, the basement of Kerala, basement rocks of Kerala. The next one.
Sir, time constraints, 5 minutes.
Yeah, I will conclude. Okay.
Okay, sir. Thank you, sir. Thanks.
Go to the next then. Skip some of the slides, please. Skip. Okay, look at this diagram, two diagrams. On the left side, what you have is the sources of sediment, as well as how the sediment is, handled. On the right side is what is actually the direction of drift and how sediment will accumulate on a groin especially, or a breakwater. Breakwaters are generally built perpendicular to the shoreline to protect a navigation canal, like in fisheries harbors. Most of the time found in Kerala, there are 13 or 20, almost 20 fishing harbors. Okay, next one. Well, this is, on the left, what you have is the sample of what is called the so-called beach profiles. We have done a huge number of beach profiles. Something like 200 to 300 beach profiles during our program in Kerala. And, take, for example, the first picture or find on the top, the first item, goes all the way down to the right. The second one doesn't go, it stops halfway. The first one is during what was done, what was the profile of the beach during a summer, during the post-monsoon season, and the shorter profile is actually what was it immediately after the monsoon erosion. Well, you know, it is from the places are indicated there where it is from. Now, I have given a cross section of as well as a seawall. The interior is left hollow. It is not like that. But there is a huge armor covering it's an engineered structure and covering the interior. So the interior smaller stones. In other words, each stone that is cladding the seaside of the seawall is a design. The size is a design size. It is taking into account the wave energy that is dissipated during a severe storm. So far, they have recorded. Then, in either case, okay, this is, for example, a very interesting picture, and it shows, I say, observed mean sea level on the Kerala coast. Date is given. We have done, this is actually a 1992 study on the coastal erosion, sea level rise due to greenhouse effect project that I had implemented in the state of Kerala. Okay, the next one. Well, this is what is called the strand plane. Okay, go back, please. Go back. Okay. On the left side, the picture on the left side is actually what is the strand plane. You can see dune ridges which are marked black. And you can see the Vembanad Lake, and you can also see the Lakshadweep Sea. So on the right side, the bar charts, what I have given is what is the erosion during its observation period and what is the rate of deposition during the observation period. Next one. Well, this is what I propose. There is no point in rebuilding reinforcing the beach again. Let the river or the river shore or the seashore, whatever it be, take what it deserves for the new condition. That is it, not the old climate, but the new climate. And build multi-story buildings for our settlers in the coast. Unfortunately, even today, most of the people who are fishers, what they want is they want to rebuild a standalone house. And that is the worst. That idea actually was sold into their minds years ago. Decades ago. But younger generation normally will not follow the thought of older generation, and they will vote for this. However, our politicians with wisdom, they always want to make permanent the disaster, whether it happens along this coastal area or whether it happens in the hill slopes or whether it happens in the floodplains or on the shores of the river. So with this, this is the new paradigm we have to accept. We have to think new for the new condition. The future is now. So let us work for the better future and not for the continuance of older past into the present and also in the future. Sabu, thank you. You heard me? No, skip all those. I'm stopping. Hello.
Hello, sir.
Thank you.
Thank you, sir.
Thank you.
Okay, thank you, sir. Thank you, sir, for the nice presentation. So we have had a very inspiring talk on the causes of coastal erosion, overview of beach erosion Kerala with wonderful slides, and finally the managing the oceans, multi-family, multi-story tenements along Kerala coast, which is a proposed project. Still, it's a dream project as far as Kerala is concerned. But I think in future it will be a reality. So on behalf of organizing committee, I thank you, sir, for the nice presentation. Due to time constraints, I am moving to our next resource person, Dr. K.K. Ramachandran. He is actually a former scientist and group head of CES Trivandrum, also former member secretary to KCST and Kerala Coastal Zone Management Authority. I have a very lengthy biodata with me, but due to time constraints, I am not going to the much details. Anyway, basically, he is a marine geologist with a first rank, and he took his PhD from KUSAT on mud banks of Kerala. He has done very detailed study on coastal sedimentation. He's an expert in geoinformatics. He headed the geoinformatics lab, as well as worked as group head of atmospheric processes in
Sure.
He was part of the Chandrayaan project of Government of India. Currently, he is monitoring committee for Vizhinjam International Seaport Limited. He is responsible for the preparation of the currently approved Kerala Coastal Zone Management Plan and still continuing SES as consultant to accomplish the various tasks assigned to him. So today he is presenting a very important topic, shoreline changes along the Kerala coast. So we have got a very eminent personality for the second session. So on behalf of organizing committee, I welcome you, sir, to this program. Sir, please.
Thank you. Yeah, thank you, Sabu, Professor Sabu. My guru, Professor Trivikramji, sir. My yesteryear's accomplices like Kanan Narayanan. Okay, I think I'll proceed to my my presentation. In fact, my job has been made much easier. Am I audible? Clear?
Yeah. 1 second. I request all participants to mute your mic. Please mute your mic and audio, video, camera.
Okay, the other day I gave a webinar to Government College Kasaragod on landslides, but towards the end, somebody told that sometimes the voice becomes a little feeble. So please get back to me if I am not clear to you at any point of time. Okay.
Sir, please share your slides.
Yeah, I'll change. Yeah, I'll change the slides. So my topic of discussion is shoreline changes along Kerala coast, and my job has been made easier by Vikramji sir by defining the sort of issues that we face along the Kerala coast. Okay, so let me go to my slides. Takes time.
No, sir, it does not come. Please click on the present now.
Yeah, that's right. And the window.
Okay, window. Okay.
Yeah.
Does not come.
I think it is getting Chrome wants to share the contents to your screen with the share.
A window, sir. Please click on a window.
Yeah, that's what I have done that, and I think it takes time to load.
Application.
Yeah. Okay.
Sir, your PPT is not on. Please on that PPT.
No, you are presenting to everyone. It has come. So.
Sir, you clicked the A window?
Yeah, okay. Okay now?
No, it was not come. It was not come. First of all, you open that particular PPT, then put it in the.
I have kept it open.
Yeah, it is in the desktop.
Yeah, it is
Then
in the
you click
desktop.
on. Yeah, now we click on the present now icon. Then go to that. I think we then click on the window button.
Yeah. Is it all right?
Presenting something has come, but your windows.
Okay.
It's not getting.
I can see the slides.
Slideshow button on the click.
You can see the slide, sir.
No, sir. Just not come.
Yeah.
Srikanji sir was telling. Hello, sir.
Yeah, I
Srikanji
can see
sir.
the slide. Yeah.
Hello, sir.
Sure.
I can see the slide, sir. Visible. I can see.
But it's not coming in my screen.
Can you see that?
Sure.
No, sir. I can.
Shoreline changes in Kerala coast. Dr. K. Ramanandran, etc.
Can you see that?
We can see.
Yeah.
Okay. Shall I proceed?
Proceed.
Sure, you can proceed. If I see, everybody else will see.
Hello. Hello.
Okay, sir. You present. Okay. Okay, sir. You continue.
Okay. Yeah. Shorelines. It is already talked that shorelines are nothing but the line marking the boundary between the land and the sea. Okay, am I audible? Hello.
Yes, sir. Okay.
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 So they are highly dynamic, especially the coast where we have the sandy sort of beach. It is highly dynamic in response to the various hydrodynamic factors, the anthropogenic factors, and it has been already talked about. I don't know. I have not attended completely. I came in only after last 15 minutes. Probably the factors that is affecting the cost must have been talked about. That is nothing other than the wind, wave, tide, river discharges, relative sea level, sediment dynamics along the coast, and the anthropogenic factors such as shore protection structures, jetties, harbors, and the other sort of facilities that we built for the recreational activities along the coast. And additionally, along certain coasts, the seismic activity also affects, and the extreme weather, of course, one of the most casualties happen along the east coast of India because of the cyclones and the extreme weather conditions. Sometimes it gets affected even the Kerala coast as well. So, a typical beach profile, I don't know to explain it. I think, it can be, you have a foreview followed by a back shore, a foreshore, a near shore, and offshore. Okay, this is a standard textbook picture from Thomson. Okay, so you can also see the different kinds of morphological features along the coast, such as berms, multi-berms. You have two different kinds of berms. Berm scarp is there. You have the berm crust, the elevated top portion of the berm, and you have the longshore trough, longshore bars, and the wave activity that is impinging along the coast, and the tide affects the coast by the systematic rise and fall of fall due to the harmonic movements. So shoreline changes can be deliberated in two scenarios, that is short term as well as long term. We have a long coast, something like 590-kilometer coast, where changes happen continuously, whether it is positive or negative. In diverse spatial and temporal scales, changes happen. In the short term, the cost changes related to the fluctuations in wave energy. Seasonally, we have the monsoons and non-monsoon, or the fair weather and rough weather seasons. Okay, so and the associated process to that. So naturally, it affects on a short-term scale. Already, Trivikram sir has told that after a spell of a very serious cyclone, what happened to the coast. And on long-term scale, what happens is that the coastal variability is conditioned by the relative oscillations of sea level, the river sediment discharge, and also the day-to-day dynamic changes that is happening, which will get accumulated, and in the long term manifest as a long-term shoreline changes. However, on an intermediate scale, on a decadal scale, factors influencing coastal changes are changes are more complex and interrelated, including both natural and anthropogenic causes. In this regard, the famous the coastal researcher Comer emphasized the role of sediment beds in coastal stability. We know that along the different watersheds that ultimately debouches into the sea, there are many barrages and dams that has been built. We have something like more than 80 dams. Okay, so river damming, construction of jetties, breakwaters, and shore protection structures such as seawall and groins affects the total sediment budget in a location. So in this space scale and time scale, with the different kinds of dynamic forcing and the response system in space and time, this is one of the beautiful classification of coastal process that has been adopted from the Larson and Cross 1995. You can see, and it's not very. You have to concentrate and see. So it takes time. So I will skip this. Okay, to explain this. So what is the most important aspect that makes changes along the coast on a short-term interval? Is the longshore current and the longshore drift. Longshore currents, how does the longshore current develop? Already Trivikram sir has told that it is because of the transformation of the waves near the shallow regions of the coast, by which the wave breaker approaches at an angle to the coast. The wave breaker approaches an angle to the coast, by which it entrains sediments that is available in the breaking zone and trajects or moves the sediment along with the movement of the current, which is known as longshore current. And sometimes it can be northward, or sometimes it can be southward along the Kerala coast, which we will come to later. So this is again an explanation of the swash backwash system, which is the zone of influence of the breaker as far as the beach is concerned. Okay. So you have the depositional shores, which are very typically, having morphological manifestations such as spit, Bay Barrier, Tombolo, Barrier Island, and deltas. And deltas are a rarity along the Kerala coast, mainly because of the very strong littoral current system that is existing. As soon as it gets deposited, sediments get distributed because of the coastal dynamics. Okay. Sabu, is it okay?
Okay, sir. Okay.
Okay.
Clear.
So, we have, those are the morphological, earlier ones are morphological manifestations of a accretional coast, whereas these are the erosional shores, normally having headland, wave-cut cliffs, sea caves, sea arches, sea stacks, marine terraces. When you see this, you should understand that at some point of time in the past, that this coast was having little more to the sea, but it has got affected because of the sea erosion. And the structures along the coast, we have the seawalls combined with sometimes groins. So what happens? Earlier I told you that the waves which come, the wave breakers which come and approach the coast at an angle, it gets blocked at an angle, and movement of the what known as longshore current takes the sediments along with it, which is known as longshore drift of sediments. So that is, in terms of the groins that we build, this is how the sediments get deposited on the shadow side of the groins. The sediment gets deposited on the leeward side. Sorry, there is a down current side from where the sediments get eroded. Okay, so I have talked about certain things which affects the cost so far. So how do we monitor this? So Srikramji sir has already told something about the short-term monitoring by means of the beach profiles. Normally we go to the beach, we select the longitudinal profile to the breaking area from the backshore, and along that straight line we are able to pick up the elevations using any instrument such as MB level or theodolite and things like that. Okay, so now we have the electronic gadgets. So even it is easy today to measure the longitudinal profiles across the beaches. So you measure in different time scales such as an interval of month or interval of 2 months, and you try to overlay with respect to a benchmark these profiles and see how much of sediment has been accumulated compared to the previous profile or eroded compared to the previous. So there is a cut and fill section that you can make from these 2 profiles or 3 profiles or many profiles that you take subsequently. But you see, I am mostly going to talk about a shoreline change monitoring on a long-term basis or a decadal basis. So for coastal zone monitoring, shoreline extraction and detection of change rates at various times has become little easier nowadays because of the synoptic images that comes from the satellite, remote sensing. Okay, so though various techniques are existing, satellite-based shoreline, shoreline tracing and comparing has become more easier as well as more scientific nowadays. So people rely the monitoring of shoreline with satellite-based data. So and based on this kind of studies, for the intent cost, recent studies by Kankara, who is from Indian Institute of, National Institute of, NIOT, National Institute of Ocean Technology, Chennai. He has conducted a study where back in 2018, 2 years back, and brought out a statistics wherein the Indian cost indicated 33% of the total cost under varying degrees of erosion, and 29% of accreting nature, and 38% of the cost is in stable conditions. But when the scalability of a study matters. Okay. So what we have done is that we have gone a little more, detail into the shoreline monitoring, and we have done the monitoring using the satellite images from 1973 to 2019 for 47 years by calculating shoreline statistics from the profiles that we have built for every 100 meter of interval along the Kerala coast. Okay, so the shoreline changes are mapped using the different satellite images, such as Landsat images, multispectral scanner system of Landsat, thematic mapper, enhanced thematic mapper, and operational land imager. All these things are from the Landsat system of satellites. So the shoreline erosion accretion scenario has been computed based on the shore normal displacement of timeline shorelines. Okay, so you see, for example, we have taken from 1973 onwards, continuously every 5 years. Every 5 years we have taken, or if it is not 5 years, for years for which the Landsat multispectral data is available, the nearest year. So like that, almost every 5 years we have taken, and if we want to find out that how the shorelines have changed over the years. So this is, Kerala coast. I don't have to do a big, long introduction to Kerala coast. Already it must have been done by frequency. So, we have a very specific kind of a coast which is oriented in the north-northwest, south-southeast direction. Okay. So, and our coast has got, we have 41 flowing rivers and 32 backwater bodies, 69 inlets, okay, at different places. We also created inlets. For example, we have, different places like Thotapalli Spillway and things like that. So, and wherever we require a tidal connection, we have made inlets, and Kerala coast is, a microtidal coast. What is microtidal? Microtidal coast is which experiences this rhythmic rise and fall of the tide to an amplitude of something like 2. Okay. So the tidal variation along the Kerala coast from the south to the north, there is a nominal increase from south to the north, and that is from 0.9 meter to 1.2 meter in the north, and it is of semi-diurnal region. What is semi-diurnal? Again, semi-diurnal is nothing but the high and low tides appear. Each high tide comes twice in a day, twice in a matter of 24 hours. Okay, so the predominant direction of longshore current along Kerala coast is towards north, which reverses towards south during the monsoon season. Okay, this is from the study of the NIO people, Kunte and Wagale. The coast is characterized by two unique regional phenomena known as Kallakadal and the mudbanks. Kallakadal has been in the talk for the last 10 years. This is a terminology actually proposed by Dr. Baba, which has been approved by the UN. This one, so the scientific community internationally, and which is nothing but heavy swells coming to the coast and inundating the backshore areas of the coast in certain areas where it is having low-lying portions. So which we have observed is it comes totally unaware, and its frequency or other sort of regularity is being monitored, but we are not in a position to predict it appropriately now. Mud banks, everybody knows it is nothing new to people of Kerala, which is otherwise known as vernacular Chagara, and which appears during the southwest monsoon at certain locations along the Kerala coast. At one time or the other, from different locations of Kerala coast, it has been reported, right from Kayankulam up to Talapadi. At more than 32 locations it has been. It is not that every year it appears in same locations, but there are consistent locations like Arabi coast or the Narakal coast of Kochi and things like that. Okay. So why these are very important, because the Kallakadal actually causes inundation of the offshore area sometimes, and mud banks causes temporary deposition, whereas there is a downdrift side for the mud bank from where sediment gets eroded. Mud bank areas normally get accretionary tendency, but the downcurrent side there could be erosion. So the methodology which we have adopted for this long-term scaling of the shoreline changes it is based on, I have already discussed about, every 100 meter we have raised a transect across the coast, and the timeline images were arrayed by appropriately digitizing the land water boundary. See, it is an automatic technique that we have adopted for digitizing the shoreline. We are not digitized as such. We have used the classification technique, the digital classification techniques by which land and water is identified, and automatically it traces the cost, and wherever there is a there is a small variation and things like that, we manually edit it and correct it. So there is a United States Geological Survey has developed the digital shoreline analysis system, and the version 4.3 we have used, which comes as an add-on tool for environmental system from the ESRI, along with the ArcGIS software. Okay, it comes as an add-on. This was used to calculate the shoreline change statistics along the study area. This method estimates the shoreline change rate by constructing shore perpendicular transect intersecting all the shorelines of study. That is it. Okay. Why we have this intersect? Because along the intersect, the various timeline shorelines will be intersecting. So by studying those intersects, we actually estimate that how much movement has taken place for the shoreline with time. Then there are two methods for this. One is the EPR method and another is LRR. What is EPR? EPR is nothing but endpoint rate. Endpoint rate means you have 1973 shoreline as well as 2019 shoreline. So you find out what is the whether one is showing erosion or accretion. Along a particular, it is not that along the entire coast that will show only erosion or only accretion. Along each perpendicular transect constructed at 100-meter interval, you have these two shorelines, which will, if one shoreline, 2019 shoreline is seaward of the other shoreline, that is 1973 shoreline, it shows that the coastline has eroded. Okay, other way, we see that it is accreted. Okay, so then there is another method which is known as LRR. It is nothing but a statistical approach using the entire set of shorelines. We go for a linear regression rate method. So adopting a, see, this is how it is being done. So you have the eroding cost as well as the accreting cost. By constructing the different timeline points of the shoreline, you get a linear regression equation which can be applied to get the rate, which is known as LRR, or linear regression rate. So this is for the accreting cost, this is for the eroding cost. So you can see the different timeline shorelines along this cost. Okay, so where you see this is actually what we call it a zone of influence, zone of maximum influence. Means with respect to by constructing all the shorelines, what is the width of that shoreline, total width of the shoreline that you get, where the total time that we consider has influenced. Okay, so this is the sort of shoreline zone of influence for this particular cost, and it goes up to 205 meters. Okay, in some of the cases, probably these are some of the accreting costs. You can see that. So this is actually an eroding cost. This is actually an eroding cost, whereas this is accreting cost. You can see that the cost is still beyond this point to a considerable extent. Whereas you can see with respect to this cost is highly, it has taken a landward position. Okay, so this is a the Panmana coast, for example. Panmana coast, we have from 1968 onwards, the shorelines were constructed up to 2018. You can see this is. You see, amazingly, the shoreline has shifted for 362 meters, and still the erosion is going on. Where they are mining the beach sand for Indian rare earths and KLLM. So this is how we have classified the cost based on the different scenarios. But if the shoreline change meter per year, if it is minus 2, less than minus, sorry, less than minus 2 means minus 2 or minus 3 or minus 4, that is categorized as high erosion. Whereas between minus 2 and minus 1, it is erosion. This is stable, and plus 1 and between plus 1 and plus 2 accretion, and greater than plus 2 is high accretion. So this is how we have classified into different literal cells. So we have classified from Talapadi to Puha, we have classified them into 6 literal cells based on so-called concept of sediment cell. Okay, so I will come to the details. This is how we have calculated the different EPR endpoint range 1973 to 89, 1989 to 2001, and 2001 to, this is for the Talapadi stretch, and this is for the Koilandi stretch. So you can see how probably the erosion happens. So we have taken 722 we have seen that 722 transects has shown erosion, whereas here 382 have shown erosion. Here 246 have shown erosion. So this is the stable, and this. So in turn, you can see that this is a cost which is eroding. Okay, already erosion has set. Okay, so then in the case of the next literal cell, you can see that this is again a eroding cost. But there are areas where you see the accretion as well. So this is how we have calculated. This is the first literal cell, which is from the Alapandi to Erimala, the northern Kerala coast. Okay, so you can see that the LRR, the linear regression, this one. See, you can see that mostly it is eroding. Hello? Yeah. Mostly it is eroding. You have some areas where you have stable cost. Okay, but you have very little accretion. You can see here. Okay, and this accretion is due to growing. Okay, so you can see that this is the zone of influence what we have calculated. Okay, this is you can see that zone of influence up to 400 meters is this color, and the green one is up to 50 meters. That means the range of shoreline shift along the coast is minimum in green and maximum in the red. Okay, so you can see from this is mostly yellow, which shows yellow and green, which shows that either it is up to 50 meters or up to 100 meters. Okay, so only very few locations like this where we see that there is a severe erosion. Sorry, severe, where we have an accretion. Actually, the accretion areas also shows the zone of influence to a greater extent. So total transects that we have covered is 863 in this. Okay, so and you can see that the maximum transects have covered in the zone of influence 50 to 100 meters. So the next one is from Edimala to Koilandi region. You can see there are certain areas where you have accretion and certain areas you have erosion. And in this sector that we had a total transect of 821. Okay. Then this is the LRR ranges for Koilandi to Kannani, that is up to Bharatapura. Okay. So and this is beyond Bharatapura up to Kochi, to the south. So you can see at several places you have accretionary tendencies, which are either due to the structures that we have erected or due to natural process. So, for example, you have white pit. See, white pit has got a huge accumulation of sediment, and which is otherwise known as Pudu white pit, and we have something like up to 600 meters of accumulation of in those areas. Okay, so the next one is from Kochi to Kollam, and in that also you can see at the places you have the accretionary tendencies, and majority of the coasts are stable, or some of the coasts definitely eroding, where we have taken 1,176 transects, and the total number of transects that we have taken up to Hua from Kollam, it is 944, and in that you can see that you have mostly stable or accreting, or certain locations eroding. Okay, so this is how we have done. This is the total scenario of Kerala coast, where we have the high erosion, stable accretion, and high accretion. You can see that there are areas like this where we have very high accretion, and there are areas like this where we have very high erosion. So when we consider the statistics from 1973 to 2019, the high eroding areas are something like 24.71%. Okay, so in fact, for the 6 transects, on the average we have taken something like 1,000 transects. If we count that, it comes to something like 6,000 transects that we have taken along the Kerala coast. Okay, little less than 6,000. You can compute 590 is the total length of the coast, and out of which we have this 5,900 and some number of transects. Where there is a bend in this one, probably we have taken closer transects. Okay, so erosion is definitely higher than the accretion cost. The accretion cost only points to something like 16%, little more than 16%, and the stable cost is 23.2. That means it comes to something like 40%. Total 40% of the area is either stable or accreting, and the remaining 60% of the area is completely eroding. Okay, or there are severe eroding areas. Severe eroding areas, we can see this 24 point, almost quarter length of the total Kerala coast is having high erosion. So this is the separation, how the linear regression rate and the EPR rate, that is endpoint rate, varies along the Kerala coast. You can see we have taken more than around 6,000 transects, and in that you can see the red ones are EPR and the yellow ones are the LRR. To get a long time scenario on a realistic basis, what we found is that the LRR represents much better, whereas there is spiking. See, these spikes are not represented in LRR. So there is spiking in terms of the total zone of influence for the EPR. It only calculates the length of shore that has been lost to us in terms of two timelines. Okay, but whereas the LRR computes for the entire 12 lines we have taken. So this is the different scenario that we have worked out from 1973 to 89, 89 to 2005, 2005 to this one. So is it that that compared to 2005, our erosion scenario has been reduced? That's all what we get. But when we compare 1973, definitely the 2019 scenario is representing a very serious eroding cost. And this is some total of how we normally represent the transects versus the different times. Transects versus the different times. You can see that 5,684 transects. So how the transects, this is the highest erosion rate. This is the highest accumulation rate. So you can see based on the color changes with time, you can assimilate that how this beautifully represents, this picture beautifully represents the different costs and their behavior with the time. This is for each district. If you don't want in terms of the literal cells, okay, in terms of the 9 coastal districts, 9 districts which are abutting the coast, we have worked out the high erosion in terms of the percentage, kilometer, stable, accretion, high accretion. This table shows all that, and in terms of the graphical representation also, it gives a scenario wherein you can see that. See, this is actually this too is representing the maximum, probably except the Ernakulam region where we have the Puduvaipu and things like that. And also when it comes to the Trivandrum coast, it is compared to this northern coast, which is not that much eroding. Okay, so this is the seriously eroding beaches around the Kerala coast, and their annual rate of shoreline shift. Okay, so this is the sort of numbers that we have for this kind of the name of the locations also given: Kumbala, Uduma, Pallikara, Thikaripu, Vadagara, Kapad, Kallai, Punnani, Rinjaram. All those things are given here. So these are the seriously eroding coast of Kerala. Thank you very much. If you have any questions, I am willing to answer. I think
thank you, sir, for the nice presentation. Okay. Participants, if you have any queries, you can switch on, unmute your mic and you can ask questions. Sir, one clarification regarding is you have mentioned that if you take the entire Kerala, right from north to south coast,
yeah,
60% is eroding beach and 40% is accreting beach.
Not accreting, stable and accreting. Stable and accreting. That's right.
So, okay. Now, regarding the sand by exiting part, where does the sand go? Is it going towards the offshore? Because
I think that's a good question. See, this we have not done a serious study for sand budgeting along the Kerala coast. But in fact, we have done for the central Kerala coast as part of a study way back in 2005, 2008. We have done a study for the along with the National Institute of Ocean Technology, I suppose. ICMAM Directorate. We have done a study in which we have done a budgeting. So what actually comes out is that, see, our input from the terrestrial system has suffered a lot. One is that. Second thing is that we have raised several artificial structures, which has actually checked the free movement of the sediments along that particular coast. And sometimes you know, when it reaches a certain threshold velocity, it is being lost to the offshore. Okay, so there are different kinds of scenarios for different types of cost. So we have done only for the Central Kerala coast, but you know, one, for example, we have a river, Bharatapuzha, which used to bring obvious amount of sediment input to the nearshore region. That is almost checked by the so-called raising 12 different locations we have reached dams. Okay, so I think I'll come to live. I'll come to live. Yeah.
Okay.
I'll stop presenting. And,
Okay. Sir,
yeah.
one question from the participant. Why the beach nourishment is not suitable for Kerala coast? Beach nourishment. Yeah.
It is not that it is not suitable. I don't think that we tell it is not suitable. But problem is that the huge investment required into that. The availability of sand, which is of very similar to the natural size that we have. One is that availability. Second thing is that to transport this. Okay, when our construction industry is suffering due to non-availability of sand, replenishing the beaches by sand deposition may not be that much, you know, may not be a proposition that will be suitable at this moment of time. You know, there are different mechanisms adopted. For example, the Puducherry experiment. In the Puducherry experiment, the beach was built by raising a offshore breakwater, or what we call the submerged breakwaters, or submerged. We call it as Kritrima Pari. In the offshore area, that you raise a submerged breakwater at which the energy of the waves are expended, by which you check the energy impinging on the coast and cut the erosion. That's it.
Okay, one more question, sir. What are the difference between sea erosion and river erosion? From one participant, Ibrahim Sheikh.
Erosion along the sea is erosion naturally, and the banks of rivers get eroded. That is river erosion.
Okay, very simple answer. Another participant.
I think Kannan has raised his hand. Yeah, please, Kannan, Dr. Kannan.
Kannan, please. Kannan, your mic is. I unmute.
You unmute your mic.
Yeah. Kannan, ask. Please ask.
Yeah, please ask. Kannan, unmute. Yeah. I am not hearing. You see, you are not audible.
Kannan, please unmute your mic if you are asking questions.
No, it fluctuates. It goes into unmute and.
Or you can
Okay,
type your question.
Okay, you please continue. Sabu, you please continue. He is asking, but I am not able to hear. Yeah.
One student was asking, mentioned the study carried out in Central Kerala. You have mentioned it in your discussion. Study carried out in Central Kerala. I don't know. It's not clear. What type of maybe coastal erosion studies carried out in Central Kerala?
No, I have talked about not coastal erosion studies, sediment budgeting. Yeah. Sediment budgeting has been done. Coastal sediment budgeting studies have been done by appropriately selecting the sediment cells along the nearshore areas of the Central Kerala coast. Okay, that is what I told. Of course, this study applies to entire Kerala, not for the central Kerala alone.
Okay, another interesting question is coastal erosion predictable?
Okay, you see, there are systems by which probably we have, even my colleague Dr. Chaudhary has tried for shoreline prediction, the numerical predictions of shoreline, and many IIT Madras have tried. Many people have tried. Any model works with correct data, precise data, probably can have a better prediction on that, and we have seen in some cases it works. Okay, like the boy who made the boat recently told that sometimes it works, sometimes it doesn't.
Hello, sir.
Yeah,
Hello.
please.
So myself, Maniandan.
Yeah, please.
Yeah, I have a clarification on that. We are constructing on a sea wall and a grounds and backwater structures on the coastal areas. In the structure, which one is the best one for the avoid the coastal erosion or avoid the intensity of waves or coastal environment?
Whatever you have mentioned, three structures are hard structures,
Yes.
and it is for different purposes.
Hmm.
So if you have a seawall, probably Trikramji has already talked about that, but it is rather, I don't know how far seawalls are effective. Okay, in certain cases, certain places it has become effective, and some places definitely it is checking the erosion, but we would have been chosen those locations by appropriate study anyway. Points are actually restricting the along shore movement of the sediments. As when the sediments are taken away from the coast by the different risk, actually the groins check and try to deposit there itself on the leeward side of the groins. So by this means you have cost. There are certain costs which are having combination of both seawall and groin. When you have combination of seawall and groin, many places we have found that though the aesthetics is lost, though the purpose of recreational activity is lost in such costs, but it sometimes controls the erosion. A combination of both. Sometimes you need only seawall. Sometimes if it is a straight cost, for example, you may be satisfied with the seawall. But if it is a little curved coast, then inclined coast, you may require both. So it all depends. How do you want? But the other one, the big one is for construction of a jetty or a harbor. Okay. So in order to traject the boats by checking effectively longshore sediment transport, by which the boats can directly enter into the harbor, be erect perpendicular to the coast, the breakwater. Long breakwater. The groins are short ones. Okay. Yeah, please.
Okay, thank you, sir, for
Have
that.
I answered that?
Yeah, okay. So one more question, sir. Yeah, one more question.
Please.
So, sir, artificial beach is good for the construction on coastal area. Artificial beach.
What do you mean by artificial beach? See, this is what I told, that artificial beach can be constructed, or artificial beach can be generated either by inputting the sand into that area, okay, or by having an offshore breakwater. Parallel to the coast, you raise an offshore breakwater, okay, and by which you control the wave energy coming near to the coast, by which the beach start building in the shadow area. Shadow which has been created by this offshore breakwater. Okay.
Okay, sir.
Please.
Okay, due to time constraints, we are stopping here. tomorrow we'll have one more talk at 11 a.m. It is about the anthroponic activities and its impact on the coast and various management options below Kerala, particularly impact in Shangumugam Beach, Chellanam Beach, etc. So I request all the participants to join tomorrow's program. We will start at 11 a.m. itself. So for a formal vote of thanks, I invite our faculty member, Dr. Bindya. Dr. Bindya, please.
Thank you, sir. On behalf of Department of Environmental Sciences, University of Kerala, and the organizing committee, I extend a very hearty vote of thanks to Professor Dr. K.P. Thirukamji for his explanation on the very relevant topic, beach erosion in Kerala, national paradigm shift for securing life of citizens. Thank you, sir. Further, we are grateful to Dr. K.K. Ramachandran for demonstrating the excellent speech on shoreline changes along Kerala coast. Thank you, sir. I also extend my thanks to our faculty members, Dr. Sabu Joseph, Dr. Salam, Dr. Jaya, Dr. Shirley Williams, and Mrs. Naomi, and all the non-teaching staff of the department for all the support. Thank you. And I extend my thanks to Mr. Vishnu, who is the man behind all the works of this webinar on coastal erosion. Thank you, Vishnu. And finally, I express thanks to all the participants, faculty members from various departments. Thank you, and thank you all.
Okay, thank you.
Thank you.
Thank you, Sabu.
Okay, sir.
Thank you
Thank you very much.
Thank you.
Okay. Tomorrow we'll meet at 11 a.m. Okay. Thank you, one and all. Bye.